Boom. Boom. Okay, now I'm recording. We're ready to go. All right. So again, I record this for people who aren't here, then they can have a look at it, right? Okay, so we're taking a note. We're finally into some chemistry here after being doing our little introduction for safety and all that stuff. So we're starting Unit 1 out of the textbook, Matter and Qualitative Analysis. And let's define a few things here so that we can get some foundation. I won't make a comment being it's going over out on the internet when the day is done. It's okay, nothing to worry about. Chemistry is the study of matter, its physical and chemical properties, and its structure and the changes it undergoes. We talked about this right at the very beginning of the class when I was introducing you to the course. What is matter? Matter is anything that has mass that we can weigh and occupies space, all right? You might think, you know, is there anything that isn't matter? Well, yeah, there are lots of things in the universe that are not matter. You might even think of some things that you don't think as being matter that actually are. Let me first address the first one. Light is not matter, all right? Light is a form of energy and that can travel through space, but it doesn't have mass. You cannot weigh light, all right? If you stop light, it ceases to exist. So if it runs into something, it either is absorbed, it becomes heat, or it's reflected and goes off in another direction. But it is not matter, okay? Space itself, scientists can measure. Space is a thing. Space actually grows with time. Way back in the history of the universe was the Big Bang, and space was really small. And then as this formation of the universe took place, space grew. So we're actually increasing in space with time. But space is not matter. It's space. It's where matter can exist. So matter is then the stuff that we can weigh and then occupies space. Air itself is full of matter. It has lots of little particles. Nitrogen molecules, oxygen molecules, carbon dioxide molecules that are zinging around right in front of us right now. We can't see it, but it is matter. It's quite a bit of matter. Even out in outer space, where you might think there's nothing there, there is actually quite a bit of matter. There's little particles that are coming off of stars, going off into space. There's not much matter there. It's very thin, but there is still a little bit of matter. Is there a place in our universe that has absolutely no matter? You know, not likely. There's always a little bit of material substance that is zinging around, zinging through space. Qualitative analysis. Qualitative analysis is used to identify an unknown substance by comparing its physical and chemical properties from those of known substances. You may have heard of a term called quantitative analysis. One uses numbers, that's quantitative analysis, like quantities, we can measure a quantity. And qualitative analysis is really just descriptions that we measure with our simple senses, like we look at the color or we can feel the texture, right? We describe the qualities of the substance. No measurement needed. Okay, let me know if I'm going too fast. Again, if you have your devices, you can jump ahead. It's awesome. So now we need to talk about these properties that we can observe. A property is a characteristic that can be used to describe or identify a substance, it's like a way to to describe it, a description. Physical property describes the physical appearance of a substance under a given set of conditions. So it's what you see when you look at it. Color, odor, density, melting point, boiling point, luster, texture, state. Those are all those things that you can describe it. Luster is whether it's shiny or not. Now, from my chemistry training, when we describe chemical substances, and in a moment we're going to write down some properties of this substance here. This is sulfur, and this is the element zinc. When I've been taught to describe things, I've always been taught to use 3 of these examples, 3 of these adjectives. And the 3 main ones that I want you guys to use when describing a substance is number 1, color, all right? So first you describe its color. And then the second thing I want you to describe, and this is a hard one to describe, it's the way light bounces off of it. So in this case, I can't see through it. So how do we describe a substance that you can't see through? What word do we use to describe something that you cannot see through? This comes from your study of optics. To oppose that, you can have a substance, and I'm looking for my gas jar. I can have a substance like water, which I can see through completely, easily see through. So how do you describe a substance that you can't see through and a substance that you can see through? What words do we use to describe that? And I'm going to go with some rookies instead of some chemistry veterans right here. I can have a third description. What if I have something like a piece of paper that I can kind of see through a little bit? Here's the 3 differences. Can't see through it, can kind of see through it, and can see through nice and easily. What are the terms? Anybody remember? Yep. Yes, kind of see through is translucent, right? If you can see through it, yep, transparent. If you can't see through it, yep, opaque, all right? If I have something like this, I could say, well, I can't see through this, so it's opaque, but it's also very shiny. So I might want to say opaque and shiny. So I always describe the color, and then I describe how light interacts with it, right? So I'm going to just put here in quotes, the light. How does the light interact with that particular thing? That's the second word I always use to describe stuff. And the third one is the physical state, all right? So I always use those 3 things. So how would I describe this zinc if I wanted to describe its color, the way the light goes through it, and its physical state? Who wants to put all 3 of them together? What are we going to describe this as? Yep. Like black. Sure. Okay. Yep. Sure, it's a solid. It's even ground up, so we could describe the solid even more specifically. What would you call a ground up solid? What do you think? A powder. You could say solid, I'd accept that, or a powder. Solid makes me think of a chunk. Powder makes me think of a powder, right? But when you describe substances, you should always contain these three things. How would you describe the water using those three descriptors? It's a trick question, by the way, especially for the first one. What's the color of water? Doesn't have one. So what word do we use to describe something that doesn't have color? Colorless. It's colorless. From the veteran. I can't hear. I wouldn't even have acknowledged the veteran if I knew it was the veteran. You're lucky. My bad ear got me. It's a colorless. And how does the light affect this? Transparent and state? Liquid. It's a colorless, transparent liquid. You can have colored liquids, right? Put a little bit of Kool-Aid in there, the grape Kool-Aid, right? It's awesome stuff. You have a purple, transparent liquid, right? All right, excellent, very good. So here we go. We're describing the three properties of zinc and of sulfur, and I'm going to get you to write these things down, and that's because we're going to look at a chemical reaction that sulfur and zinc can undergo in a moment. So describe three physical properties of zinc and sulfur, and we've already done the zinc, and I would say it's more gray than black. But hey, that's just me. There's the sulfur. All right. I'm going to write in the zinc, except I'm going to put gray. Gray. Opaque. Did I do that right? It's opaque, right? I got to stick an E on the end. I'm serious. I really, that's one of my pet peeve words. I hate it. We like it? It's good? Opaque. And solid, powder, it doesn't matter. I'll put powder, because in this case it is powdered. I won't be that particular picky, like on a lab when we do that. If it's a powder and you write solid, hey, that's awesome. It's not that big of a deal. Sulfur, what do we have for sulfur? Somebody have an answer there? Jessica, you got something for sulfur? Did you look at it, write it down? No? Anybody? Somebody? It's right here. It's our sulfur. Sure, you're now all questioning because I turned this black into a gray. Come on, you got to agree with me. That's gray, isn't it? Like, come on. Is this black? What? They match? All right, black. All right, videotaping here. We're making that a black. Making that black. Yes, sir? One. Oh, actually, it's frozen. You can take both of those. One of them is frozen. Oh, you can take that one, too. I thought you liked paper, Mr. Petrus. Yep. Oh, you're going to give me this? Good. Yellow. Oh, oops, I made that an A. Opaque. I hate the word opaque. Oh, you said powder, right? Powder. That's good. I'm putting this on the internet for all people to see how bad my spelling is. That's all right. Excellent. Physical properties of zinc and of sulfur. Let's talk about chemical properties. And let's take a look at the reaction between zinc and sulfur. You can write the chemical properties part. Don't write demonstration. But in a moment, we're going to describe the chemical property between zinc and sulfur. And then that's the homework. And that's all I have for today. All right? Which means when we're done our demonstration, which we're going to do across the hall because that's where we've got a fume hood, because it's really a kind of a stinky, messy demonstration. Once we get back, you can work on your things you need to work on, except you took your device away. I can see if I can find some with Mr. Edgar. So a chemical property, let me finish with this video here. So properties of matter, as opposed to descriptors of matter, we're just describing them a moment ago. Now we want to talk about their properties. A chemical property can only be observed when a substance is changing into a new substance. So we're going to see some evidence of chemical properties, all right? When we see our demonstration, we're going to see evidence of a chemical reaction. Iron produces rust in the presence of oxygen and water, and so we will see a color change if we were to see the rust. We're going to see some examples here in a moment of some, again, evidence of a chemical change in a moment. So I'm going to stop there. There's one kind of practice problem you can do. It's in the textbook. Again, if you want to leave your textbook here, you can, and you can access the online textbook to answer that one question, or you can have your textbook with you. I'm going to stop my recording here.